Hey viewers, we're back. We're going to talk a little bit about multimeters and circuits. I had a little interest in the function of multimeters. We're going to talk real quick about that. I'm going to fire up a quick circuit here and demonstrate Ohm's law real quick. It's not going to go into a lot of theory yet, but I'll expand on these things in another video that will be coming shortly. Anyway, the multimeter that I used on the car battery video was this multimeter. This is an old Radio Shack multimeter, 30, 40 years old, but they're all basically the same. Here we have the power button, and we have DC volts, AC amps, DC amps, ohms. Those are the voltage, current, and resistance sections. That's the most important sections and the most used sections. And we have F is for farads for measuring capacitors, HFE, small signal current gain for NPN and PNP transistors, and that about does it. So we turn the power on here, and you can see the power is on. It's ready to measure voltage. So we can come on a little tighter. Here we have a circuit, and I'm going to draw the circuit, but here's the circuit on a breadboard. We're going to prototype circuits in some future videos also. And here we have the power supply, which is something like a battery, but this is a variable power supply, so we can make it whatever volts we want. And we want to measure a voltage. To physically measure a voltage, we want to, first of all, connect the voltage or not. It doesn't have to be connected to measure it. You can measure it here without it being connected. And there we have minus 12. I have the polarity reversed here. Reverse polarity again, a bit over 12 volts. On the circuit board, it's going to be the exact same thing. The wires have near zero resistance, close enough. We measure from one power supply to another, power supply connection to another, and there we have it, 12 volts. These are two 100K ohm resistors. We'll talk about units of measurement like volts and ohms in a future video. But we have two 100 kilo ohm resistors. So basically we have a voltage divider. So if we measure across one, we should have 6, and we do. If we measure across another, we should have another 6, and we do. If the resistors were of different values, we would have different voltages there. That's how we could deliberately get voltage values using a voltage divider. Anyway, that is how to measure volts. We have a ground, black, and we have a red, which is usually plus, and we usually put the black on ground, the positive or red on the incoming voltage, and that's how we measure a voltage. To measure a resistance on this meter and on lots of meters, we want to go and switch the dial from volts to ohms. One of the ohms values, the largest value, but still small enough to be close to what you're measuring. In this case, we need to switch the leads from the little lightning bolt signal to A ohms. You can see the A ohms. That means amps or ohms. You're measuring current or resistance at that point. If we want to measure resistance, we want to disconnect the power. Don't want to measure resistance while the circuit's under power. Now we go across a resistor, 99.5 or 6,000 ohms, 100 kilo ohms. What about this one? 99.243. So that is how to measure resistance. Put the leads together, it's a dead short. have 0. We have 0. So that's how to measure. And the circuit that we were just looking at looks like this on a schematic. We have an incoming power supply. We have a voltage divider, 2 resistors. This is how a resistor is drawn in electronics. 200 kilo ohm resistors, a 12 volt supply, plus for the long plate, minus for the short plate. Current flow is a whole other subject, and we'll get to that in another video. We measured here and here to ground. That's a ground symbol. So is that. So we put the red lead here, and then the red lead here, and we had the black lead here. Here we had the 6 volts. Here we had 12 volts. Same as the battery. And that's how to use a multimeter, and that is how to measure voltage in a circuit. Thank you.